Welcome to qnawire.
Okay, so this is the force diagram for the roller. Let's take a look at the moments about point O. Consider counterclockwise moment is positive, clockwise moment is negative, and this will give us Fa times 150 millimeter minus Fc times 150 millimeter is equal to 0. So I have Fa is equal to Fc, which means that the friction at point A is equal to the friction at point C. So now let's apply force equilibrium for the roller. So we have net force along x direction is equal to P minus Fc minus Na cosine 30 degree minus Fa sine 30 degree is equal to 0. Na here is the normal force at point A, and P here is the force that was applied. And along the y direction, we have Nc plus Fa cosine 30 degree minus Na sine 30 degree minus W is equal to 0. W here is the gravity of the roller. So now let's take a look at the force diagram for the tube. So we'll consider the x direction of such model here is along the surface, and the y direction is perpendicular to the surface. So now let's take a look at the moments about point D, which is the center of the circle here. So consider counterclockwise moment is positive, clockwise moment is negative, and this will give us Fa times 150 millimeter minus Fb times 150 millimeter is equal to 0. So we have Fa is equal to Fb, which means that the friction at point A is equal to friction at point B. So now let's apply force equilibrium for this case. So we have net force along x direction is equal to Na minus Fb minus Wt sine 30 degree is equal to 0. So we have Wt sine 30 degree is equal to Na minus Fb. Wt here is the gravity for the tube. And now on the y direction, we have Nb minus Fa minus Wt cosine 30 degree is equal to 0. So Wt cosine 30 degree is equal to Nb minus Fa. So assume that the slip occurs at point A. Therefore, have Wt sine 30 degree is equal to Na minus Fa, which is equal to Na minus mu A Na, since we assume that slip occurs at point A. So the friction at point A now is the static friction. So if you do some arrangement here, eventually we'll have Na is equal to Wt sine 30 degree over 1 minus mu A. We know Wt, which is the gravity of the tube, can be equal to mass times the acceleration of gravity, which is equal to 392 Newton. And we know the coefficient of the static friction at point A is given as 0.2. So we can plug in these values back into the equation to determine the Na. Eventually, we'll have the normal force at point A is equal to 245 Newton. So now let's determine the normal force at point B, which is Nb here. And this is equal to mu A Na plus Wt cosine 30 degree. If we plug in the values, eventually you have Nb is equal to 388 Newton. So remember, Fb, Fc, and Fa are both, not both, all of them are equal to each other, okay? Which is equal to 0.2 times 245 Newton, which is equal to 49 Newton. Since Fb and Fc is equal to Fa, so we can just use mu A times Na. Mu A here is 0.2, Na here is the 245 Newton, okay? So now remember, force P can be equal to Fc plus Na cosine 30 degree plus Fa sine 30 degree. And this will give us such equation here. So eventually with the calculation here, we'll have force P is equal to 286 Newton. So now in order to determine is this value the smallest value for the force P, we need to compare the maximum friction at point B and C and the friction we had in this question. So the maximum friction at point B can be equal to mu B and B, which is equal to 0.3 times 388 Newton, and this is equal to 116 Newton. And from the roller diagram, we know that W can be equal to Nc plus Fa cosine 30 degree minus Na sine 30 degree, which will give us Nc is equal to W plus Na sine 30 degree minus Fa cosine 30 degree. If we plug in the values, eventually you have the normal force at point C is equal to 1060 Newton. So now let's determine the maximum friction at point C, which is equal to mu C Nc, and this can be equal to 0.4 times 1060 Newton, which is equal to 424 Newton. As you can tell, the friction we got from the question is less than the maximum friction at point B, and the friction we got from the question for the friction at point C is less than the maximum friction at point C. This means that the slip will not occur at point B and C, and the minimum value for the force P is equal to 286 Newton. And these are the answers for this question.